Hello, good morning, and welcome to our second day of doing our chapter 4, which is constructing and interpreting scatter plots. If you remember, we started the note packet yesterday, the new one, chapter 4, and we are going to be on the back side of that first page today if you're in my class. And we're going to start by giving some formal definitions of three words that we talked about yesterday, and that would be cluster, gap, and outlier. So let's remember what we talked about. So a cluster, when we're doing scatter plots, like the ones pictured below, is a group of points that lie close together on a scatter plot. A gap would be an area that contains no data on the scatter plot, and an outlier is a point that is set off from the other points. If you need to pause the video to get the three definitions, you should do that now. Okay, so our lesson today, though, we are going to go through examples 2, 3, and 4 to talk about scatter plots that are already constructed and label them and talk about them. Okay, so example 2 says, Rochelle asked 10 friends how many hours of sleep they got the night before a math test and then matched that data with their scores. She plotted her data in the graph below. What kind of association does this graph show? Label any clusters, gaps, and or outliers. Did the students who slept more get higher test scores? Okay, so if you look at this data, we have a trend going on, right? So our data is traveling as the hours of sleep go up, right? The math test scores also seem to be going up, except for this guy right here, okay? So like starting, this looks like maybe it's 5 hours of sleep. This person probably got a 65 or 70 is the estimate. But as we go across, 10 hours of sleep for this guy got 100% and on up. So we call that a positive association. What kind of association? This is a positive association. Okay, and so what that means is, and that's a kind of a thick marker, so I will change here. What that means is that as hours of sleep go up or increase, the math test scores increase in general. And so that's not true for everybody though, right? And so this one guy right here, it looks like he slept, or she, 10 hours, but still only scored about a 40%. So the next thing says label any clusters, gaps, and outliers. So this one right here would be an outlier because it is not in our pattern. Ooh, sorry, there's an R there. It's not in our pattern of data here. So that would be what we would call an outlier. So maybe that person had something else going on. Maybe they didn't study. Maybe they missed a bunch of school ahead of time, and so they scored poorly. Maybe they had a lot on their mind. So that's an outlier. Oh, I don't know why I put an S on that. That's one outlier. Okay, so that means that this right here would be a gap between the data. And our clusters, right, we have a bunch kind of in a row. We kind of have two clusters. We have a cluster right here, and we have a cluster right here. And so those are the ones that are together. All right. Let's do another one. Okay, so let's move on. So example 3 is another scatter plot in another situation. So this one says, Avery is a middle school basketball statistician. Ooh, she tracks the number of minutes a player plays and the number of fouls a player makes. Her data are shown in the scatter plot. Is there an association between the number of minutes played and the number of fouls made? Wow, okay. So this is how many minutes are being played, up to 20 minutes here. And then this is the number of fouls. So if you look at this data, is there a trend where if a player is playing more minutes, they're getting more fouls? or if the player is playing more minutes, they're getting less fouls. There's nothing really happening here. The data is kind of clustered and sprinkled all over. So we would say there is no association. So what that means is that we cannot make the determination that the more minutes played means the more fouls made. There's nothing that we can say about that according to the data that's given. And so in this one, there aren't any outliers, clusters, or gaps either, because there's no association in the first place. Okay, last but not least then, and this is where some kids might get confused. So I'm going to talk about this data. It says Avery also tracks the number of minutes a player plays and the number of points the player scored. Describe the association between the two data sets and what that suggests. Excuse me. Wow, I can't talk this morning. So in this one, it's different. This is the minutes they play versus the points they score. So is there an association this time? So it's kind of linear, constant going across in a couple of places. So at 6 and 8 minutes, that's about 2 points. And then right here we've got an 8 and then probably a 10 and a 12, and they're all at 4 points. And then we're doing this thing here, but it's still kind of traveling in that positive direction. So you can say that this is a positive association. Okay, and then so in this case, what this means, what this suggests, is that as the number of minutes played increases, that the number of points scored increases as well. As the number of minutes played increases, the number of points scored increases. And that's exactly what they're trying to ask us here about what that data suggests is by making that association, we can say that, okay, minutes played goes up, points scored goes up. Okay, so that's the second part of our lesson, to interpret that data. And the assignment that will go with that today, if you are in my class, is in your book, and it would be pages 222 through 224, and that's numbers 1 through 12. Okay, if you have any questions, please make sure you email me, and I will get back to you as soon as I possibly can. Have a great day.